Hi there, this is Adam McQuiston with the Coding Interface, and in this video I want to use the Python-based Click CLI framework to make a clone of a popular Unix CLI command called WC. So if, for folks not familiar with the Unix WC command, let me go ahead and just quickly pull up the man page for WC. So WC is used to count words, lines, characters, and bytes in input files. So, the first line of the description here reads, the WC utility displays the line numbers, words, and byte counts contained within one or more input files and displays that to standard out. And so you control the WC program by passing in some optional parameter flags saying what you want to be counted. So you can count the bytes again with a -C, you can count lines with -L, and you can count characters with -M, although generally the bytes and characters are pretty much all the same, except for in some weird circumstances that doesn't hold true. And then the final one is -W, which counts the words in the file. And the output is generally always in the same order, so if we read here, the order of output takes on the form of line, word, byte count, and then file name. And then they have an example of how you could use the WC program to analyze two files named report1 and report2. And the specific counts, again, are words, bytes, and lines. So let's see this in action real quick, actually. I'm going to make a couple of dummy files just to play with for demonstration purposes, and they're going to be quotes from famous software engineers or computer scientists. So the first quote will be by Martin Fowler, and let me go ahead and grab this quote that I have off on the side here, paste it in. And so this quote from Martin Fowler reads, any fool can write code that a computer can understand, but good programmers write code that humans can understand. And I particularly like that quote. It's a good motto. The next one, so the one will be by Linus Torvalds, so the famous inventor of the Linux kernel or Linux operating system. So let's say Linus Torvalds .text will be the name of the file, and I'll paste in the quote here from Linus, and that is, any program is only as good as it is useful. Also another very interesting quote, and I threw in an emoji there at the end just to demonstrate that you can you can work with non-standard text characters and programs should work. Alright, so if I want to run these two files through the WC program, I can just come down here to my terminal and write WC, and then let's say Martin Fowler, followed by the Linus Torvalds file quote, and we see the output right there. So this is reading the Martin Fowler file, has 2 lines in it, followed by 18 words and 112 bytes. And then the Linus Torvalds quote is made up of 1 line, 11 words, and 50 bytes. And then there's a total line at the bottom that sums the total for all the inputs. So this is what we want to emulate in this video, or what I will demonstrate emulating in this video, is a Python-based CLI command, and I will call it PYWC, like what we see here, just so we can easily differentiate which one is the standard WC command that's been around for quite some time, and then the clone of it being PYWC. All right, so let's jump into the implementation. So I already mentioned I'll be using the Click framework, and I will also create a setup.py file so that I can pip install this as an installable package with a command line script entry point. So let me say from setup tools import setup, and then I'll go ahead and implement this setup function, and I'll give it the name of PYWC, And then we'll give it a version of version 1.0.0. And then after that, let's say we'll say PyModules to specifically call out that we're going to utilize a Python file named pywc. And then Python version requirement. So if I do Python requires, then I'm going to say that we want to use at least version 3.6 of Python. And then we're going to say that the install requires the following library. So let's say click greater than or equal to version 8.0. And then last and certainly not least is in entry points for console scripts, and that's going to say our pywc CLI command should map to a pywc file, and within that pywc Python file, a main function. So just like that. All right, so since that's done, the next thing to do is to start implementing this pywc Python file. So, I've said a few times now, we're going to be working with the Click framework. So I will import Click right at the top here. And then we just saw that this pywc is expecting a main function. And then I will also throw in a bit of boilerplate code down here at the bottom. This isn't actually 100% necessary, but it's a good practice. That way, if something invokes our program other than the Click framework, so such as, I don't know, just want to run it one-off without being Click enabled, I could go ahead and do that. All right, so I imported Click, and the way to turn this function into a proper Click command handler is to use a Click command annotation above it. And then another thing that's important to do is a docstring. Now, docstrings are important for a lot of reasons, for just regular everyday Python programming. However, with Click, they hold a little bit of extra value in that whatever I put into this Python docstring will actually get parsed out and shown in a help page that the Click framework is going to construct for me, which is super awesome. So I will say this is a Python clone of the Unix WC program. Fantastic. All right, so I'm down here in the same directory as my setup.py file that we just created. And so what I'll do is I'm going to create a Python-based virtual environment. So Python 3-m vem. So that created a new Python virtual environment named venv here, which means I'm going to have an isolated version of Python sitting in there. And then I will activate this with a source vem bin activate. And then I will pip install this installable program like so. So pip install -e for an editable mode. So that means I can make updates and I don't have to reinstall. And then I want it to install what's in the current directory, so period. Very cool. So if I now do a pip list, we can see that my pyc library or pyc application and command was installed right there. So that also means that I can do a pywc --help, and I get a nice help page just right out of the box from using Click by annotating this guy here. And like I said earlier, it parsed out my function docstring to be used in this help page. So the usage is you execute pywc and you follow that by options, which the only options right now are the help option, but we will swiftly move right along and start to continue to build out the functionality here. All right, so we saw that the wc command expects, or the pywc takes one or more files to read in as input and to count the various things like lines, words, bytes within each file. So the way that you enable a click command to take an argument is with another click annotation called click argument. And you give it the name of the argument. So I'm going to say inputs, right? And then I'm going to give it a type also of click file. And I want this file to automatically be opened in read mode. So I'll throw a -r there. And since I executed pip install in editable mode, I can actually already just start seeing the functionality here. So if I do a pywc -help again, I now see that I have an inputs argument. It doesn't necessarily tell me what type of argument it is, but I can see that I have an inputs argument. So, if I up arrow a few times and I show the wc command running again, notice that I gave it 2 files rather than just say 1. We want to emulate that functionality. The way that you emulate having a variable number of arguments in the Click framework is to use a keyword argument called Inargs. And if you're only going to ever specify 2 arguments, or 3 or 4 or 5, then you would use 2, 3, or 4 or 5 here. If you want to accept a variable number of arguments, you throw a -1 in there, and that will take anywhere from 1 to however many your program can handle. So now I could do this exact same thing where I specify 2 files or however many files I want to with my pywc program. So let's start handling these arguments a little bit. So the way that you get control or gain access to these arguments is you specify a function parameter, so of the same name. So inputs will be a list of files fed into the program. Now let's demonstrate how we can work with these files a little bit in a stepwise fashion. So one thing I could do is I could just iterate over each file in inputs, and I could print out like what file was being used. Now we know we're going to count things, so maybe that sounds like a good use of a custom Python class. So let's create a custom Python class called dataRow. And dataRow is going to have an initializer, so an initialization constructor, and it's going to take name. Because down here we see in the output of the wc command the counts followed by the name of the input file, except for the very last row, which the name is total. So name will hold the name of that very rightmost column. And so I will say self name and make that a proper class field. And then I'm also going to establish 0 initialized fields for the other things that we're counting, like lines equal to 0, and then self bytes equal to 0, followed by self words equal to 0, and last but not least, self characters equal to 0. So that means I can create an instance of my row class, and we'll say row is equal to data row, and then I'm going to pass it file and give it the name of the file, like that. So now I can iterate over each line in the file. So I can do a for line in file, reading 1 line at a time, conserving memory. And I can use the click echo function to print out to the screen anything I want to standard out. So I'm going to use an f string, and I'm going to say, well, let's print row name, and I want that to be right aligned, and I want to pad it always to 18 characters long. And then I'm going to do like a little arrow pointing to the specific content of that line. So I'll do line. And then each line is already going to have a new line character on the end of it, as we see here. And so what I'll do is in my click echo, I'm going to say, I'm going to update the NL character or NL keyword parameter to the echo function. And I'm going to say, don't give me a new line. So NL false. All right, so at this point in time, I should be able to run my pywc command over the Martin Fowler quotes and the Linus Torvalds quotes, and I think it will print them out. There we go. So we can see the 2 lines from the Martin Fowler quote and then the 1 line from the Linus Torvalds quote. Very cool. All right, so we've made good progress so far, but we haven't quite fully cloned the functionality that we expect to see out of this and matching to the WC command. So let's progress on. So if I re-pull up, so if I do a man once again on the WC, we see that we expect to have flags for C, L, M, and W. And the C flag, again, are bytes, L are number of lines, M are characters, and W are words. So we need to figure out how to implement those. Well, those are actually called options. So we annotate our main function again with the option decorator from the Click framework this time. And I will do a -C and then a help. And I'm going to go ahead and flip right over to the is flag part. So is flag is a keyword parameter to the option decorator. And what this basically means is if -C is specified in the pywc command, then it means it's a Boolean, right? It means like, hey, I want you to count whatever C represents, which are bytes. So let me make a couple of copies of that, and we'll do the same thing for L for lines, and then also M for characters, and then W for words. And I'm going to say, start filling out my help text. That should come with each option. And that's going to say count and then something in each input file. Okay, so the first one were bytes. So count bytes in each input file, and then -L meant lines, -M meant characters, and -W were words. So that's how you enable your click command to have options. Now, of course, this needs to map down to the parameters to our main function, which are just going to be C, L, M, and W. All right, so let's go ahead and let me make sure that came through in our help text. So there we go. We got pywc, pull up the help page, and we now have options specified as well as the type that each option should be. So these are all text options. And they specify whether or not, oh, I'm sorry, these were supposed to be true. So these are not text options. These are Boolean flag options. So let me make that true. And when we run that, I'm glad we looked at the help page. All right, so these are all Boolean flags. And there's our help text right next to each flag, telling you exactly what each one means. Which actually I think is a bit of an improvement over the man page for the WC command. In fact, the WC command doesn't even have a very good help page really kind of at all. It just gives you this much. So we're already improving upon the base implementation. All right, moving on. Let me come down into the body of my main function here. And so by default, let's pull up that man page one more time, make sure we're fully implementing and cloning the functionality of WC. And if we look through the documentation in the man page, there's this line right here. It says the order of output always takes the form of line, word, byte, and file name. Okay. Then it also says the default action is equivalent to specifying -c, -l, and -m. So that's two important pieces of information. So that means if you don't specify any flags, so if I were to well, come back to our example, right? I'm not specifying any flags here, and yet I'm still getting the lines, the words, and the bytes. So that's what we need to emulate. So let's say show default. We'll make a variable called show default, and we would show the default if none of these flags have been specified, which would also mean they're all false, right? So by default, a Boolean flag, if it's not given with the command, is going to be false. So let's say not any of C, L, M, and W. So if none of these are true, show default is how that should read in your mind. And I'm also going to make a total row. So this is going to be this last row right here. And that's going to be a data row once again, but the name of that row is total, we see. All right. So I won't need this echo line anymore. However, I will need to start incrementing the values for lines, bytes, words, and characters for each row, right? So that's fairly easy to do, right? So we do row, and then the bytes field is plus equals, so increment by len of, well, line as text to begin with. So let's encode that to UTF-8 bytes, and that will give me the bytes that are present in that line. Row lines is super easy, right? So just every single time we go through this loop, we increment that by 1. And then we have row chars, so for characters, that's just equal to the length of line, right? So that one's perhaps just about as easy. And then how do we count words? So if we do row words plus equal, well, we're going to count the length of something again. But this time, we're going to say line and then strip to get rid of any leading white spaces or trailing white spaces that might be present. And then I'm just going to say split. And split will naturally split on any white spaces. And so if you split by white spaces, that leaves you with just words. All right. Now, the last thing that really kind of remains to be done is we need to update the totals, right? So we got that totals row here, and we'll increment that by just looking at row bytes. And we'll do the same thing for the other fields that we're interested in. So we got lines, and then we'll increment the total characters based off of the rows characters, and then words, same way, off of the rows words. All right, so once again, I want to get output, so I'm going to use clicks echo, and but I want to format this in a very specific way, right? So we see down here, things look to be right justified, right aligned for our data columns, but this output field name, or the far right column, appears to be left justified. So I think is what I'll do is I'm going to outfit this data row class with a function that returns its data formatted nicely in a similar type string. So let's call this, I don't know, what's a good name? Maybe output. So we'll say output is equal to self. And then we need a way to just tell this logic which fields should be shown. So let's just specify that with something very straightforward like show lines, and we're going to default that to false. And then we'll say, well, show characters, again, we'll default to false. And then we'll say show words, and we'll default that to false. And then we'll say show bytes. Again, we'll default that to false. And it's kind of a long method signature, but that's okay. We're not going to worry too much about the look and feel of our code right now, and if we wanted to, we could implement some sort of linter to be a little more opinionated about that. So the very first thing we need to do is we need to figure out the number of columns of output we expect to have, right? And of course, that's going to map to however many of these are set to true. So let's make a variable of number of columns, and that's going to be equal to the sum of show lines, show bytes, show characters, and show words. And so in Python, right, every true value really represents like a 1 in mathematical operations. And a false value is going to represent 0. So I can just sum all the true values, and that tells me the columns that I expect to see in my output, right? So that'll tell me the number of columns. And so again, remember I talked about how I want to pad things a certain width and to right or left align various things. So I can use string formatting syntax to do that, but that means I also need to create a variable, some sort of variable way to specify that. So a good way to do that could be to make a list, which I'll call formats, and I want to specify that they are right justified. So that means I use this right caret here, and we'll say roughly 8 characters in width, right? So we want them all to be padded with 8 characters and to right justify the content. And we want to do that number of columns time. So this will map to something that looks like, I don't know, 1, 2, 3. You know, if we're saying we're going to show 3 of those, then it's going to look like that 3 times, basically. If number of columns were to be equal to 3. All right, and then no matter what, we always want the output name as the final column. So let's just say formats append, and this one looks to be a little bit longer, and we already realized that it's also left justified. So we'll flip the direction of that caret, and we'll say 20 as a some random number that's a little bit longer than 8. And then the overall format, so FMT, will be equal to the joining of this list right here, right? So that will build us a good format template to work with. Perfect. All right, so you know, that gives us our formatting template, but we also need to figure out which fields need to go where. And so if I just make a fields array, sort of similar to what I did with the formats array, right? So I initialize an empty fields array or list, and I can say if show lines, then append that to fields. If I can spell fields, okay. Append self lines. And the next thing to show, so we got lines listed first, then we got words. So if show words, fields, append, self, words. The next thing is bytes. So if show bytes, fields, append, self, bytes, right? Last but not least, if show characters, fields, append, self, characters. Right on. So that constructs our fields in the proper order, with the exception that we need to obviously add the name. So fields, append, self, name. And last but not least, we just return format. So we split this out So format, and then call format, because remember format is really just a string. And then I can simply explode out the fields list using the splat character, right? So star. And that will generate a fields output. Awesome. So let's put that to use. Let's come down here and we'll say row output. And I'm going to make a new line here. And I'm going to say show lines is going to equal to L. So from our flag here, L. And so if L is true, or show default. We'll do the same thing with all the other remaining fields. So bytes, what was bytes? Bytes was C, or show default. And then show words equal to W, or show default, right? And then last but not least is show characters, and that was just equal to M, because that was not part of the default view. All right, and then I don't really like the unequal indentation there, so let's bring that back out one. And last but not least, if more than one file is given, then our inputs list will be longer than one, right? So I can say if len of inputs is greater than 1, then let's do the same thing, but with the totals row. So was it total or totals? Total row. And that should give us identical functionality to the WC command, if I am correct. Yeah, it looks all good to me. Let's run it. So pywc Martin Fowler and Linus Torvalds. Whoops. Row object doesn't have a line. Looks like I missed an S somewhere. So right there. Any other spot? Nope, that looks good. So let me rerun WC, and now we'll run that one. And look at there, looks like I'm slightly off on spacing. I'm not gonna worry too much about that, but all my other numbers match up, and the general format looks identical. So let's do, just for fun, let's count lines just to be sure. So Martin Fowler, and then Linus Torvalds. All right, now let's do the same thing with the Python version of this. All right, right on. Looks like we've made a perfect clone, essentially. All right, I hope you found that interesting. That's how you can use the totally awesome Python Click-based CLI framework to create a Python-based CLI. I hope you found that interesting, and if you're interested in learning more about this, I actually have a several-hour course on the Click CLI framework that covers it in pretty great depth. So if you want to learn more, check that out. There's a link below. Thanks for stopping by.